Hello everyone. So welcome to my channel. So now we are discussing about the current electricity. So in that one, series resistance and parallel resistance. So what is the difference between series resistance and parallel resistance? So how we need to find out? So whether it is a series resistance and parallel resistance. Supposing question. So so they are giving resistance. So R1, R2. So how we need to find out whether it is the series or in whether it is in a series, whether it is in a parallel. So there are certain points you need to consider. Suppose here it is a series resistance. So it's connected R1, R2. Resistance is R1 and R2 resistance. So in series resistance, the current is same in the series. So the current is same in series. So here the current entering from here. So I is there. So same current flowing, the same current passing through the R1 and R2, same current. The current same in the series resistance. So first point. So in series resistance, the current is same. The current, the current I is same. The current I is same in series resistance. సో మనం ఏదో ఫైండ్ అవుట్ చేయాలి. సపోజ్ కరెంట్కి వెళ్ళి కరెంట్ ఎంటర్ అవుతున్నప్పుడు దీనికి బ్రాంచింగ్ లేదు, కరెంట్ డివైడ్ అవ్వట్లేదు, సేమ్ కరెంట్ పాస్ అవుతుంది. సో R1 R2 సేమ్ కరెంట్ is passing through the R1 and R2 resistance. So it is the series. So next the voltage is divides. So voltage divides nothing but current enter అయిన తర్వాత చేంజ్ చేయాలి. సో ఎంతో కొంత వోల్టేజ్ అలో చేస్తే కరెంట్ అనేది రెసిస్టెన్స్ నుంచి పాస్ అవుతుంది. త్రూ అవుట్. సో the voltage is divide. The voltage is divide. The voltage is divide. So here, voltage, suppose if I want to find out the V1 voltage in the R1 resistance. So V1 is equal to IR1. Okay. Next V2 is equal to IR2. So here the voltage is different, the current is same. So you have to remember the 2 points. The voltage is divides and the current is same. So before going to identify whether it is a series or whether it is a parallel resistance, so you have to consider the 2 points. So first one current and next one voltage. So in the circuit, the current is same through the R1 and R2 resistance, and the voltage divides nothing but it is in series. So you have to consider the 2 points. So the current is same through the R1 and R2 resistance, and the voltage divides nothing but it is in the series. Okay, before going to identify whether it is the series or in a parallel, you have to consider 2 points. Suppose the current is same and the voltage divides, so it is in the series resistance. So there is no branching is also there. So here the current is also not dividing. The same current is flowing from the R1 and R2 resistance. Suppose if I increase the resistance in the circuit in the series, so if the resistance is more, so then the more voltage required to allow the resistance. So if I suppose the resistance increase చేస్తే ఏమవుతుంది, సో ఇంకెక్కువ వోల్టేజ్ అవసరం ఉంటుంది. So the more voltage allowed to into the resistance. So suppose next finally how to find the equivalent resistance R equivalent. So what the formula of the R equivalent? So R equivalent is nothing but R1 plus R2. R1 plus R2. So next you need to find out the parallel resistance. So in this parallel resistance, here you have to consider the 2 points. So one is current. So here the current is divides. So due to branching, so here the I current is entering into the circuit. So next it is dividing into 2 parts. So I1 and I2. So I1 and I2. Here the current is divides. Here the current is divide. Here the current is divide. Okay. Next, the potential difference is same across the 2 points. Suppose if I consider the potential difference from here to here. Okay. So what the potential difference across the 2 points is same. So the potential difference is same in the parallel resistance. The potential difference is same. So in parallel resistance, the current is divides and the potential difference is same. So you have to consider the 2 points. So whether the current is dividing or the current is same, you have to find out. Suppose the current is dividing here the I1 and I2, nothing but it is the parallel. So you have to consider the 2 points. First, the current is divides. Next, the potential difference is same or not. So across the 2 points, between the R1 and R2 resistance, the potential difference is same for the R1 and R2. Okay, so it is satisfying the two conditions. So it is in the parallel resistance. So రెండు కండిషన్స్ సాటిస్ఫై అవుతాయి. సో అది ప్యారలల్ రెసిస్టెన్స్ లో ఉందండి. సో హియర్ suppose if I want to find out the R equivalent resistance. So R equivalent resistance. So R equivalent is equal to 1 by R1 plus 1 by R2. Suppose if I want to find out the voltage in R1 resistance, so voltage V1 is equal to I into R1, I1 into R1. So V2 is equal to I2 into R2. So this is the formula for the series resistance and parallel resistance. So here generally we are applying the Ohm's law. So V is equal to IR. So we all know about this Ohm's law. So simply applying the Ohm's law in this series resistance and parallel resistance, we will get the answer. So next we discuss about the one problem here. So series resistance and parallel resistance. So here it is one series is there. So 2 ohms. So it is connected in series 2 ohms and 3 ohms. So find out the equivalent resistance. So R equivalent. So it is connected in a series. So the formula of the series resistance R equivalent is equal to R1 plus R2. So R1 plus R2. So you can write as a R equivalent is equal to R1 2 plus 3 is equal to 5 ohms. So next parallel resistance. So 2 ohms, 3 ohms, 6 ohms. So here the current is dividing here. So I1, I2, I3. So you have to find out the R equivalent. So R equivalent is equal to formula for the parallel resistance R1. So 1 by R2 and 1 by R3. Okay, so substitute in this formula. So R equivalent, so 1 by R equivalent is equal to 1 by R1, nothing but 2 plus 1 by R2 plus 1 by 3 plus 1 by 6. 2, 3, 6. So simplifying this up. After simplifying this, you will get the LCM 2, 3, 6. See the 6. So next, so you will get the 3 plus 2 plus 1. Nothing but 6 by 6. So answer is 1 ohms. R equivalent is nothing but 1 ohms. So this is about the problem regarding the series resistance and parallel resistance. We have to find out the R equivalent. So resistance, R equivalent resistance. Next we discuss about the another problem here. So first, so you have to find out the R equivalent in this circuit. So first of all, it is in series or parallel. So in series lo unda parallel unda. So how we to find out? So you have to consider the 2 points. So first one, the current. So the current in the circuit is same or not. Suppose the current entering from here and exit from here. The current is entering from here, from A, and exit from the point B. So here the current is dividing here. So you have to observe carefully. So I1 and I2. The current is dividing. So I1 and I2. Nothing but, so it is also one of the conditions for the parallel resistance. So next, the potential difference across the 2 points is same. So from A to B, what is the potential difference here? So here 0 volts voltage. The potential difference from the A to B is 100 volts. So same. So the potential difference between the R1 and the R2. So same resistance. So the potential difference is also same for the R and R, right? So first you have to check the current entry and current exit. So direction of the current. Next, the condition of the parallel circuit. So it is dividing, the current is dividing. So you have to check the conditions for the parallel circuit, the current is divided. So first one, okay. So next, voltage is same, the potential difference is same across the resistance, okay. Next, so here 100 ohm, the potential difference across the 2 points, nothing but here 100 volts entering into the from A. So next here also 100 volts, okay. So before entering into the resistance, the voltage is same, okay. After entering to enter into the resistance, the potential difference, so after the voltage, so it may be different. So here before entering to the resistance, the voltage is 100 volts, okay. Here 0 volts, nothing but the potential difference is 100. సో ఇక్కడ మీకు రెసిస్టెన్స్లో ఎంటర్ అయిన తర్వాత ఎంత ఖర్చు అవుతుంది 100 వోల్ట్స్ అనేది. సో నెక్స్ట్ ఇక్కడ వచ్చిన తర్వాత నెక్స్ట్ ఏమవుతుంది, ఇక్కడ 0 వోల్ట్స్, ఓకే. సో ఇక్కడ కూడా 0 వోల్ట్స్ ఉంది. సో ఈ పాయింట్ దగ్గర కూడా 0 వోల్ట్స్ ఉంది, ఓకే. ఈ పాయింట్ దగ్గర కూడా 0 వోల్ట్స్, ఓకే. ఇది సి అండ్ డి అనుకోండి సపోజ్. సో ఫ్రమ్ సి అండ్ డి ద వోల్టేజ్ ఇస్ 0. సో వోల్టేజ్ 0 ఉంటే ఇందులో కరెంట్ ఎంటర్ అవుతుందా? సో కరెంట్ ఎంటర్ అవ్వడానికి ఛాన్స్ ఉందా? లేదు కదా. సో 2R రెసిస్టెన్స్ ఉంది కదా. సో the point C and D voltage is 0. If the voltage is 0, then the no current flow through the 2R resistance. So 2R resistance li current enter avutunda? Avvadu kada. There is no current flow through the 2R resistance. Then the resistance R and R. So then the resistance R and R is parallel to each other. So enduku parallel each other? So here the current divides and the potential difference also same. Here also 100 volts. Here also potential difference 100 volts. The same potential difference. So here the 2R is not having the potential difference. So it is never pass through the 2R. The current never pass through 2R. So next you have to find out the R equivalent. So then you conclude that it is the parallel resistance. So we are conclude that it is in a parallel resistance. So what is the formula of the R equivalent for the parallel resistance? So what is the formula? So R equivalent is equal to 1 by R1 plus 1 by R2, so plus 1 by R3 up to 1 by Rn. So 1 by R1 here, the 1 by R plus 1 by R. So we can write as a 2 by R. So it is a reciprocal, right? So we get the R equivalent is equal to, so R by 2. So answer is R by 2. So R equivalent is equal to R by 2. So first you need to find out, so whether there is a parallel resistance or series resistance. So what is the condition for the parallel resistance and series resistance? So you have to check the current and voltage potential difference. So whether the current is dividing or not. So whether the potential difference is same or not. So apply the conditions of the parallel resistance and series resistance. So then you have to solve this problem. Okay, this is about the series resistance and parallel resistance. So next we discuss about the remaining topic. So regular watch చేస్తుండండి, సబ్స్క్రైబ్ చేసుకోండి. థ్యాంక్ యూ ఫర్ వాచింగ్.